In this module, we will look at how some of the ideas outlined earlier can be applied in the context of an urban sanitation project or a broader urban development project. It must be stated at the outset that no two projects follow the same trajectory, and there may be other independently managed activities and documents that can be brought into the project process, as well as the project team's accumulated knowledge and that of their country counterparts. This also means that not all the tools will be needed in any given situation. They should be seen simply as resources that may be useful to decision makers and to those who prepare and implement projects. This slide shows the steps in a typical project cycle, starting with identification and the development of a project concept through planning and design to implementation and finally evaluation. The lessons learned from the evaluation should then feed into the design of a subsequent project. Some of the details addressed in these different phases are shown on the slide. Here is the table of how the tools discussed in previous modules might be applied in a generic project. As you can see, the various tools can be used at different stages of the project cycle. In the case of a project prepared in Lusaka, for example, the starting point was the preparation of a sanitation master plan for the city. Such plans, however, often focus on infrastructure development and normally propose the expansion of sewerage at great cost to the city. Even though areas that are earmarked for on-site sanitation may be identified under a master plan, little consideration is usually given to prioritizing between them, to identifying how on-site systems will be designed and constructed, etc. Moreover, the issues involved in creating a fecal sludge management service chain are also usually not addressed. At an early stage in project development, a fecal waste flow diagram, or SFD, was prepared for Lusaka, which highlighted that the biggest sanitation issue in the city is, in fact, fecal sludge management, or FSM. This is very important information to present to decision makers and service providers in a city, as they may be reluctant to engage with FSM if it is a service they have not formally provided before, or if there are concerns about how to implement FSM solutions, how to cover its costs, etc. There may also be prejudice against pit latrines, which are sometimes seen as dirty, polluting, or inappropriate sanitation solutions. Latrines are often poorly constructed in rapidly urbanizing neighborhoods, but the extent to which they pollute the groundwater as compared to septic tanks and sewers, which exert a much higher hydraulic load of polluted water, should be analyzed in the city in question. Groundwater pollution from sanitation systems can be an important consideration in a city. By way of example, Lusaka draws almost half of its water supply from karstic aquifers beneath the city, and so a groundwater vulnerability map was prepared in order to understand this issue better. The preceding information can then be combined with the findings of the Urban Sanitation Status Index, which, in the case of Lusaka, was based on a geographically stratified survey of about 1,500 households across the city in order to prioritize project interventions. For Lusaka, the combined information clearly shows that the largest concentration of poor sanitation is in unplanned peri-urban settlements, which sit almost entirely over the area of maximum groundwater vulnerability. This information provided a clear basis for prioritizing non-networked sanitation interventions. The City Service Delivery Assessment and the Prognosis for Change tools can then be used to draw out the key institutional constraints and to develop a politically feasible roadmap for providing sustainable sanitation service provision under the project. A city service delivery assessment was prepared in Balikpapan, Indonesia, for example, and highlighted a need for better management of the downstream end of the FSM service chain and a more systematic approach to the full service delivery chain by the local authority. Although the service outcomes were rated as quite good, this was mainly due to services provided autonomously by the private sector. As a result of this information, the city moved to develop sludge treatment capacity and to oblige service providers to use it, as well as to improve containment and emptying in poor unplanned neighborhoods. In the Indonesian city case, these were issues which the SFD had identified and the service delivery assessment further highlighted as not being addressed by the authorities. The project design stage takes the project components identified and outlined in the initial conceptual description and translates them into plans for infrastructure and for developing the enabling environment and the institutions which will provide and oversee the sanitation services. At this stage, it is also useful to identify early interventions that can achieve short-term results as a means to further consolidate support from the key stakeholders and to thus gain further traction for the project. Insights into the political economy and the potential for change can be very useful to inform which early interventions should be prioritized. The Service Delivery Action Framework builds on the results of the Service Delivery Assessment and the Political Economy Analysis. It is designed to indicate the next steps in building up sustainable service delivery arrangements starting from the current situation. These steps can then be translated into technical assistance and other supplementary inputs to be provided under the project. In the cities of Maputo and Beira in Mozambique, for example, technical assistance was provided for a revision of the sanitation bylaws in order to recognize and allow for the regulation of FSM services provided by both the public and private sectors. In Balikpapan, the authorities built on the Service Delivery Action Framework to move towards scheduled emptying. The Intervention Options Assessment process is an engineering process of comparing solutions and cannot be substituted by the use of tools. However, by adopting a systematic approach that takes into account the whole sanitation service chain, technology choices can be matched to the specific challenges previously identified, drawing on technical expertise and up-to-date reference material, and validated with the responsible authorities, service providers, and users. A key external resource for this design stage is the material produced by Iwerg Sandek, which clearly lays out in one place much of the technical knowledge around sanitation and fecal sludge management technologies. As a result of having undertaken such preparatory design work, project interventions are identified. In the case of Lusaka, these include interventions to upgrade latrines to make them easier to empty, to develop small-scale service providers to empty latrines in unplanned areas, and to install, transfer, and treatment facilities to deal with the fecal sludge collected. The tools I have described in this module are focused on diagnostics and project preparation and design, impact monitoring, and the learning of lessons at project closure bring the cycle full circle, and the basic diagnostic tools, SFD, USSI, and CSDA, can then be rerun to assess progress made under the project, how sustainable it is, and what lessons can be taken forward for the design of subsequent projects. In summary, the material we covered in this module looked at the following aspects of the project cycle in its different stages: identifying problems and risks, identifying and prioritizing interventions, identifying management and institutional issues, designing institutional improvements, designing the physical interventions, monitoring outcomes, and evaluating the lessons learned to feed into future project designs.